Hey, what's happening, guys? It's been almost 9 months since the last video, I think. So yeah, right away, if you saw any of the previous videos, you would notice the interface is a bit friendlier, right? I added fancy icons for values like health and score and energy. I added this animated progress bars or whatever you call it. Another thing, I'm not actually playing the game right now. It plays itself. And yeah, you might also notice we have enemies running around now. They trying to chase the player if they can reach him. Otherwise, they will be just moving randomly. Yeah, the way they implemented both autopilot and AI, they use a Pathfinder, which is basically a simplest Dijkstra implementation straight from Wikipedia. So yeah, it's pretty much the pseudocode. And the only difference is probably this weird buffers that I use, which are basically to avoid reallocation on every tick or however often we're rerunning Pathfinder. And so the way AI works is we run update on every tick as usual. We are checking where is the player position. If player is moving, we actually targeting the target position of a player, right? So we are not like chasing his old spot. If player position changed, we are rerunning Pathfinder. And also, even if the player is at the same spot, we are rerunning Pathfinder from time to time because paths might change, right? We have rocks falling from the sky and previous path might not be available anymore. The way Pathfinder works to be sort of generic, it accepts two functions. First one is whether an entity can move to a certain position on the grid. And the second one is what is the cost of moving to this position. So in case of AI, an enemy's movement is pretty straightforward. The cost of movement to a certain position is always 1, right? So more steps you take, the longer the path becomes. And after running Pathfinder, dist buffer would basically be a 2D array of distances to each position on the grid. And so when it comes to autopilot pathfinding, it's a little cute because we don't want to find the shortest path somewhere. We actually want to find the longest possible path a player can take to survive as long as possible. And the way it works in this game is by using weights or like cost of moving somewhere as a negative value, not as a positive as we have seen before. This also comes straight from Wikipedia. In direct acyclic graphs, we can find the shortest path in the graph minus g, right? Derived from g. And by doing so, we would get the longest path. And so now the way it works is because we inverted the weights, right? You can see they are negative on the grid. The shortest path in terms of what Dijkstra thinks is actually a longest path. So the way the pathfinding for enemies actually work is that we are running Dijkstra once from the player position. And Dijkstra gives us a minimal distance, shortest path towards each position on the grid that we have. And then we can use this information from the point of view of every enemy to find the shortest path towards the player. And yeah, you can see this with the numbers right now on the grid. And I can also just try to hide from enemies and they will be running around on their little island themselves until I teleport there if I get unlucky. Okay, so two other features that I added due to really overwhelming demand from the comment section was idle animation for a player. Not really idle, it runs all the time. If you look, it's a little subtle, but you can see it. And another one is teleportation. One other feature that was added is this sort of animation on the grid tile, which represents a time you have until you will fall, right? There is a limited amount of time you can stand at one place without moving. And so now it's easier to spot how much time exactly you have left before you need to move forward. And so the way I implemented it is actually with a fragment shader. I'm not the best person to explain this, but yeah, very briefly, progress would be a value from 0 to 1, representing how much time we have left, right? 1 being there is no time and it's time to fall. To understand it better, yeah, the Book of Shaders is a nice website. But basically, using cosine of any value, we will always get an output between -1 and 1. In our case, we're using apps to cut the negative part, so we will only be getting values from 0 to 1. And then by multiplying it by some constant, we can change the frequency, right, of our wave or our animation. Then we're also using a step function to just set a threshold when we want to start blinking. And we also control the redness based on progress and whether we are blinking already or not. And then we get the final color of our texture, ground texture, by mixing actual pixel color value from the texture with our red color value. And the third argument is basically a value used for interpolation between first and second color. And the way it's used, if we actually go into rendering of our ground tile, so we are checking if there is no player on the ground, we just render in ground texture. Otherwise, we are using raylib's functionality to begin shader mode with our configured shader to draw the texture. And shaders are managed in the same way as assets, right? We're just using go embed to load shader code, and then we use raylib's built-in methods to compile and load the shader and also set uniform values. Yeah, so one other interesting thing I've done is related to rendering text and templates. So as you can see, we have text here when we select in a skill or on the screen in general, level and health and energy and score or impact numbers. And so I was originally using string concatenation or formatting from Go standard library, but what I noticed in Profiler is that, as expected, there was quite a lot of allocations happening because of these string operations, and I ended up implementing my own sort of fast template functionality. And so the way it works is we basically take our template string, split it by variables, and store result in chunks. And we only do it once when we create a template instance. And then when we want to render a template, we combine chunks and variables in the right order into bytes buffer. And then we just return like a string view over this resulting buffer. But we need to keep in mind that if you execute template one more time with different variables, it's gonna also change the underlying buffer. So yeah, as soon as you get your string, render it, and then you can move on to the next one. This crazy thing is not something I came up with. I was basically taking a look at string builder from Go implementation. It has the same thing. And the only reason I didn't use it is because the reset method is basically assigning buffer into nil. So next time it will reallocate underlying like back in storage. But buffer reset implementation actually retains underlying storage. And this is what I wanted, right? I want to avoid reallocations as much as possible. Yeah, one other thing, when we actually want to use a integer variable inside of our template, I'm using minimization, right, or caching of values, so we don't create a new string every time. And I have a bit of a benchmarking for different ways to construct a string from a template, using my template and converting integers to string every time using E to R, using my cached method, or just using sprintf straight away, right? And yeah, we can run benchmark and see how it works. And yeah, you can see, so if you are concatenating strings or using sprintf, there are allocations happening, and they are slowest ones, and tests that use my template implementation, they don't have any allocations. So yeah, I think that's all I've got to show today. Not quite sure what's going to be the next step or timeline of updates, because I also started working on another game concept recently, obviously before finishing this one. Yeah, if you watched so far, maybe I can give you a little sneak peek. It's going to be a tower defense game. It's going to be super awesome. I'm doing the best UI. Look at it. Super responsive. and you can use keyboard too. Boom. Yeah, so you roll, you build weapons, combine them all together, become stronger, and you survive as much as possible. But yeah, anyway, thanks for watching and take care.